Hello, this is Dave Hammer. Today we're going to continue working on the Cricut Utility Air Hammer. All videos and pamphlets produced by David Hammer are copyright protected. The Cricut videos are available on YouTube for free viewing at this time. I do not give permission for the content to be downloaded nor used for any commercial gain. Metalworking projects require the use of shop equipment. Please exercise caution when using machines. These videos are offered without accepting any liability for your experiences. Your safety is your sole responsibility. This video is the fifth in a series that provides information about how the original Cricut Utility Air Hammer was built. This episode covers the construction and installation of the stroke adjustment assembly. The roller valve, a component of the air circuit, is mounted on the stroke adjustment assembly. The roller valve interacts with the ramp on the ramp dock assembly. Each time the roller on the roller valve moves up or down the ramp, it sends a signal to another air circuit valve to reverse the direction the ram is moving. This is a picture of the stroke adjustment assembly without the roller valve. The roller valve is stationary while the hammer is in operation. Its roller interacts with the moving ramp dock assembly. The position of the stroke adjustment assembly, specifically the roller valve, determines the position of the stroke. The stroke adjustment assembly is used to move the position of the stroke. These are the three sub-assemblies of the stroke adjustment assembly. This is a complete assembly on the left, and then the parts that are required to build it. The piece of square tubing needs to slide easily onto the tower. We need to first remove any burrs and the welding seam that's on the inside. I'll use a belt sander to skinny up the tower a little bit. Take the edges off. Try another tool on that seam. Let's knock the corners off of the tower a little bit. Finally. There it goes. Next, we need to make a swivel point for the handle. Need to skinny down this 1/2 inch round so it'll fit in that bearing. What I called a bearing is just a short piece of heavy wall tubing. Cut off about 3 inches. Next, we're going to draw the outline of our handle. About a 1/2 inch from the right side, make a line 9/16 down. About a 1/2 inch from the left side, come down about 2 3/4 inches. Draw the kind of grip that you want on your handle. I chose something fairly simple. Close your eyes, tap your toes 3 times. Obviously, you cut that out on a bandsaw. Make it pretty. Round all the corners so it's easier to use. Clamp it for welding. That's where that 3 inch piece goes. Weld and then grind it smooth. There I am grinding again. So that's our handle. Work on the inside corners with a file if the action is not smooth. Drill a hole and put on a keeper. You do this on a drill press. Center punch all holes before you drill. Draw a 1/4 inch slot about 4 inches from the end. Cut that out. Then cut a piece of rod long enough to stick out about a 1/4 inch, and then weld that pin in and clean it up. Bend this over about 30 degrees. Grind a flat spot on our bearing. Slide the bearing on the handle, then clamp the handle on the sleeve. Don't worry about attaching that little piece of plate that you saw a second ago yet. Just be sure the handle allows it to be placed against the side of the sleeve without interfering with the handle operation later. Be sure that indent you have on the left side of the handle is just in a little bit from the edge of the sleeve. Weld the bearing onto the sleeve. Make sure all this works smoothly. Grind or file it as necessary. Next, we're going to drill a pilot hole all the way through about 1 inch from the bottom of the sleeve. Take it apart. Change the bit to 3/8, then enlarge the hole in the handle. And set that aside. Drill a 3/8 hole through the top of the sleeve. That's on the handle side. Put a 1/2 inch bit in and enlarge that hole to 1/2 inch. Make sure that the action is smooth. Take a 3/8 rod and work it down a little bit on a belt sander so it fits in the hole in the handle. Mark it at about 3/4 and then cut it off. That's going to become a pin. Push it through from the back for a plug weld. Then weld it. And then grind it back smooth. Put this together, and if the pin hangs up, enlarge the hole in the sleeve. Put the keeper on. Make sure everything works smoothly. The pin will lock into any hole in the tower. The roller valve will be mounted on the plate. The plate will be put on this assembly, pushed against the bearing. The roller valve will be mounted in this position. So we'll make the holes for the roller valve on the plate next. Line the roller valve up with the end of the plunger about 1/8 of an inch beyond the edge of the plate. Use a skinny grease pencil to mark mounting hole positions on the plate. Drill holes with a number 7 drill bit. Tap for a 1/4 20 bolt. Clamp it together. Weld it and clean it up. I want to put a limiter on that plate so the handle can't be pulled out too far, so that the handle travel is limited. Position that stop so the pin just gets out of the sleeve. Weld that stop on as shown. This will stop you from being able to pull the handle out too far. Clamp a short piece of 1/4 inch round about 2 inches from the end of the sleeve. This will be for a spring. Not a good picture here, but weld that on and then clean it up. Put the handle in the assembly. Put the keeper on. The tower that you're working with right now shouldn't have any holes in it yet. This is just a sample piece. But this should all work smoothly. If it doesn't work smoothly, you need to enlarge the holes or file grooves or drill a hole for the spring. Here we're going to mark on the handle where we want to start the bending. To take the handle off to the end, we'll heat it up or whatever and do the bending to the shape that you want. Next, we're going to install the stroke adjustment assembly. You can see here the ramp dock assembly sticking down. Remember, the ramp dock assembly moves up and down with the ram. The holes that you see on the tower are the stroke adjustment points for the original Cricut. The assembly slides up and down on that tower. This is a stop which prevents the assembly from moving down further than that. So let's put the roller valve on. Next, we have to establish the position to mount the stroke adjustment assembly, specifically the tower. This is the position the tower needs to be mounted. The tower needs to be vertical with the roller just off of that surface, maybe 1/16 of an inch off of it, or a little less actually. After careful measurements for placement of the tower, design and make the brackets. You can use existing bolts that are there for the tower brackets. Put the brackets on. Drill holes in the tower as necessary and bolt the tower on. Double check your clearance on the roller. Next, we're going to mark a position for a stop on the stroke adjustment tower to limit how far the assembly may be lowered. Move the adjustment assembly so the roller is about 1.5 inches below the ramp. Use a Sharpie to mark where the bottom of the adjustment assembly sleeve is on the tower. This is where you weld on a stop to restrict the downward movement of the assembly. Remove the stroke adjustment assembly. Weld the stop on the tower. Coming up next, we'll be marking where the holes will be drilled in the stroke adjustment tower. At this time, the table spacer, the lower die, the ram assembly with the upper die in place must all be mounted. The dies must be touching with the ram assembly tight in its operating position. Directions for making the table spacer are covered in part 1 of the air circuit installation video. The lowest hole is positioned where the lever locks in when the assembly is pushed down to the stop. The second hole up is 2 3/4 inches higher. The remainder of the holes are 3/4 of an inch apart and are drilled to within 4 inches of the top of the tower. Mark the hole positions, then drill 3/8 inch holes 1/2 inch deep in the center of the tower. Chamfer the holes with a larger drill bit so the lever pin can lock in easily. Ensure that the action works smoothly before installing. Reinstall the stroke position assembly. Let's take a look at the hammer cycling. First, I'll let the air into the air circuit. Then I'll operate the hammer as if I was using the treadle. As previously indicated and easily observed here, each time the roller on the roller valve moves up or down the ramp, a signal is sent to another air circuit component to reverse the direction the ram is moving. Sweet! The roller valve is generally stationary while the hammer is in operation. When the operator moves the stroke assembly up, you can see the stroke moves higher. He's actually moving the center of the stroke, or lower. This normally is not done while the hammer is running. Next, we're going to make and install a back support for the ramp dock assembly. This will help prevent that assembly from wobbling from pressure from the roller valve during hammer operation. There shouldn't be much movement here, but any is too much. This is the backing we're going to create. It's high-density plastic bolted to a bracket. Use this visual to fabricate one. It's basically just part of a piece of angle iron with plastic bolted to it and a piece of 1/2-inch square welded in to keep it from twisting. Use an existing bolt hole to mount it. Tighten it up. Push it right against the ramp dock assembly. The piece of 1/2-inch square bar on the back of it rests against one of the uprights you see there. I absolutely love watching this action. Cool. If you decide you don't need to adjust the position of the stroke, like for a specialty hammer, you could simply mount the roller valve in a static position. Most home-built hammers would not have this feature. This is Dave Hammer. Thanks for watching.